moving a little bit away to extend from the question of shapes in mathematics and the interaction of mathematics and arts. And much rather, we're now looking a bit more towards the sort of the link that I tried to bring to the exhibition, the link towards physics, to the sciences, material science in particular. And so here, basically, I want to first give you a few words about the research that's going on in my group, a little bit introducing the 3 panelists that are sitting here, and then basically we will do very similar to what the other sessions did. They will all say a few words about themselves. We'll have a little bit of a discussion amongst ourselves about 2 topics, and then basically open up to you. All right, so if you've been to the exhibition, you already saw these nice shapes here that have been contributed by various people, and essentially motivated by that. I mean, in my group, what we do is we really work on this interaction between mathematics and the sciences. So my group is called the Mathematics for Materials Modeling Group. Here are a bunch of very nice people. And I'm situated in both institutes, and sort of the thing that interests me, that interests the people in my group, is how basically by, for example, simulating materials from the first principles, meaning using principles of quantum physics and understanding from the atomistic scale how materials work, how we can use this knowledge to bring innovation to engineering, like how can we find new materials, make things that we have better. And these simulations are challenging. So what I mean by that is that it can really happen that for one material you need to wait a week until you have the answer. So that's what I mean by challenging. But nowadays, people really use this as the first step to come up with new materials. So people run this in the millions, okay? And yeah, our goal in my group is really to understand how can we make these things faster, more reliable, when do they break, and if they break, what can we do about it, how can we fix it? And that is really where, in my opinion, the role that mathematics has to play to understand the structures of these things. And what's fascinating me about this, and also what basically made me in the end agree to participate to this exhibition when Mark approached me, is that the longer I am in this domain, material science, the more I discover how much mathematics there actually is, right? So we saw a talk yesterday about some of these ideas, how mathematics design can help to shape maybe the new construction materials of the future, I would say. And so really what fascinates me is how not just numerics and simulations, but also pure mathematics really has a say in these kind of applications. So I will talk more about this when we have the tour through the exhibition. But here, this Hofstetter butterfly, for example, is really for me a synthesis of all of this, because it's actually a Cantor set, it's a fractal set. And for example, these branches you see here, they follow 1 over n, where n are the integers, so it has a connection to Chern numbers, to topological effects, and so on and so forth. So there's really a deep mathematical connections in these sets. And a little bit guided by these geometrical pictures that you see here are the questions also that I want to pose to my panel and discuss with the panel and with you. The question, okay, I mean, there seems to be somehow geometry and patterns popping up everywhere. So is nature maybe inherently geometric? Or is it basically just us who, have this geometric mind and we basically just try to find the patterns everywhere? So is it us who bring the patterns to the nature, or is it something that's inherently there? And then the other way around, maybe actually our thinking in terms of structures that we see mathematically or that we see in the way we depict things, is this maybe something that we use to imitate what we have actually perceived in nature, or is it something that stands by its own? And related to that, exactly this interaction of arts and science needs very naturally, in my opinion, 2 questions related to scientific visualizations. So then the questions that I pose here and want to discuss a little, is scientific visualization a form of art? Is it influenced by art? Should it be influenced by art? May it be influenced by art, right? So what is the tension here? What is the mutual interaction? And basically, to what extent should it have an interaction? All right, that's pretty much without further ado what I wanted to say for my introductory words. So here are the panelists that you already see here. So I will start in the order of the panelists. So the first is Gregor Jotzo, a colleague of mine in the material science department, works basically on the interaction of light and materials. He will tell you much more about this. And I think his interest is really, I put it here very bluntly, geometry and physics, right? So I think this is kind of the participation and the mutual interest here. Next one, we have Vineta Gerganova. So she is right now a free consultant. I'm sure she will talk to you a little bit more about this. Interest is in communication, media relations, offers these services to companies and so on. And I think for her, it's really this interaction of arts and science that drives a lot of the things she's doing. And the third one is Julien Meyer. He is working at the National History Museum in Luxembourg. Is really the one responsible and leading mediation and public engagement. So he is a mathematician, but clearly the interest here is science and people. How can we bring those things together? And I think without further additional ado, I would just hand over the word to Gregor, who will give us a few minutes of introduction from his side.